Okay, this one is the fox problem. We are looking at a fox population and we get to assume that it varies sinusoidally. We start at t equals 0 and we hit a minimum number of foxes of 200 after 2.9 years and then a maximum of 800 after 5.1 years. So I'm just going to sketch to give myself a little bit more of an idea. Okay, so 2.9 and 5.1 years are pretty crucial. So we'll say this is about 2.9 and then this is about 5.1. And 2.9 was a minimum of 200 and 5.1 was a maximum at 800. Okay, so that's half of a period. So I'm visualizing this. And then it will repeat itself. So it should be back down to a minimum. Oh, I'm going to have to calculate. What is that? 3.2? Oh, I'm sorry, 2.2, I'm going to say, not 3.2. So it took 2.2 years. This should take another 2.2 years. So 7.3, I think I'm seeing. And you could work backwards as well. If we go back 2.2, that would tell me that at 0.7, there should be a maximum. Okay, so that's pretty good start going on this one. I don't know why I always get so crooked at the bottom. Not very to scale there. 5.1 is maybe a little far over, but I think that'll get us the idea. So if we want to write a population, it looks like, what do I know? It looks like a full period is 4.4. Which means my b value, the one that gets hooked to my t, should be 2 pi over 4.4, which you can just leave it as that for this problem. You could make it pi over 2.2. It's kind of weird to have decimals in fractions. You can convert if you want, but I actually, for my purposes of checking, kind of like just seeing the 2 pi over or the pi over, but whatever is fine with that. For equilibrium and amplitude, the middle of this one, these are kind of nice numbers. So 200 to 800, that's a total height of 600 for my wave, which means the amplitude is 300 and equilibrium will have to be at 500. So if I'm putting this all together, did I get variables? Y equals is already there. Okay, so this t is my time variable. So I'm going to say pi over 2.2 times t. And then I need a plus 500 for equilibrium. And out in front, I'm going to need a 300 for amplitude. And now, before I can decide on phase shift, I need to decide if I want to use a sine or a cosine. And it is totally up to you. What I would say is that right now, we have some really good information on maximums and minimums. So I think it would be easiest to just use a cosine. If you've noticed that 0.07, or I'm sorry, 0.7800, you could just take a cosine wave and shift it to the right 0.7. So t minus 0.7 would work beautifully. The point we were actually given, in case you didn't go calculate that, was this 2.9200. And I think this is what I saw most commonly, so I'll write it. But there's multiple correct answers as always. So that I think was the most common one I saw. And let me not forget that 300 needs to be negative. That might be getting just out of your window a little bit. Here, can I scooch over? I don't think I can, but it should be negative 300 out in front. Okay, and then I highly recommend checking a graph, and then we'll use the graph to check some of our other answers as well. So I'll head over to Desmos. And I do have this typed in just so you don't have to watch me do that. But I haven't messed with the window yet, and you can see that this does not fit in the window that I have from whatever I was last messing with. But we kind of know what this should look like. If you remember back to what your graph was here, I want to see up to 800, and I looked at least to 7.3 years, so we could go more than that, but that should get me a decent window. So let's go y-axis. Let's go up to 850. Ah, looking better already. And then maybe about 8 years. Okay, so that's not too shabby. And we can double check and see There's the 0.7800 we talked about. There's the 2.9200 that we were actually given, and the 5.1800. This is looking pretty good for those 2 points that I was given. The next question asks us to predict the population when t is 7. So you could try to just drag along here. Oh, I'm on the wrong side already. Okay. And see, sometimes you can hit it spot on. It can be a little tedious though to get there. Up there, I did get it. But what I would say is sometimes it won't even hit spot on. And rather than trying to mess with that, you can just go in here and say x equals 7. It is a little picky. It let me use the t variable up top, but it behaves a little weirdly when I do that here. So I would recommend doing the x equals. And then you can just click right on that. And we'll run around roughly 227 is what I think I'm seeing there. Okay. Part C does require an algebraic solution, but we can check our answers graphically. So let's work through the algebra first, and then we'll go see if it looks like we're matching up. We would like to know when the population is equal to 300. So we'll set our formula that we just wrote equal to 300. I don't know why I'm missing a set of parentheses up here. That looks weird. Okay. So to solve, I'm going to subtract the 500 first. We'll get negative 200 equals negative 300, cosine of all that same stuff. And then we can divide by negative 300. Those negatives cancel. So I've got positive 200 over 300, which reduces really easily. I'm going to just go ahead and do it to 2/3. And then as soon as you've isolated the cosine, this is when you get to start thinking about unit circle. This is when we can say, well, that's saying the x-coordinate on the unit circle is 2/3. So if I think about my unit circle, that's going to be x-coordinate. So we're going to get a point in quadrant 1 and in quadrant 4. To get one of those points to get us started, we'll use a cosine inverse of 2/3. And then we'll have to do the work to figure out what the other one is. I get roughly 0.84 as that first arc length to get me started. So that's going to be this one, 0.84. So to get the bottom one, we could use Maya's favorite. We could just say it's negative 0.84, or it's absolutely fine always to do 2 pi minus 0.84. Sometimes for a word problem, that actually will save you a step because it'll get you the positive solution, but we'll see where we end up. Okay, so we're going to say we've got this pi over 2.2 times t minus 2.9. That's our angle. And that's going to be equal to roughly plus or minus 0.84 plus 2 pi k. And we'll need to multiply both sides by 2.2 over pi. So all of this needs a 2.2 over pi. And over here, 2.2 over pi, which will just wipe it out, which leaves us with t minus 2.9 is approximately plus or minus 0.59. And then that 2 pi k, when we multiply by 2.2 over pi, gives us our 4.4 k, which that was the period that we started with, right? Our goal was to get that 4.4 to be our period. So if you're going to remember, you can go ahead and just tack that on at the end and skip the 2 pi k algebra, but I know that I'm prone to forget and just tack on a 2 pi k, even though I know it should be 4.4. So I always just tack it on then to catch myself. Okay, and then our last step is going to be to add the 2.9. We'll have to do that in 2 separate steps here to get the plus or minus. So I'm just going to write it out, and then I'll calculate what each of those are. So I'm getting 3.49 approximately, and a 2.31 approximately. And I did store all these numbers as I worked with them. So I didn't actually use the rounded 0.84 and the rounded 0.59. If you aren't going to store and use the answer in your calculator as you go, just use a few more decimal places to make sure you don't build up a bunch of rounding error. And then these both have the plus 4.4k. So our directions were to look for the first two times. Actually, I think we did pretty good. You won't always, but what I'm seeing is that if I start subtracting 4.4 to get smaller solutions, both of those will be immediately negative. So I can't get any smaller than that without getting negative numbers. And if I add 4.4, I'm going to get something way bigger than either of those. So it's the 3.49 and the 2.31 that I'd like to keep here. Okay, and then the last question is really just a graph question. So if we're looking at 2.31 to 3.49, are we getting the times when the foxes are endangered when it's below 300? Or are we getting the times when it's above 300? We can also use the graph to check our solutions that we just got right now and make sure they really are the first two. So here's my graph, and I put that y equals 300 in for you. And we can check, there's the 2.31 and the 3.49. So our solutions are looking good. And between those 2 points is when the population is below 300. So for that last answer, it's below 300. That's the times when the foxes are in danger. Okay, let me know if you have any other questions about that one. I'm happy to look at it more.